Hi, and welcome to another one of my videos. Today I'll be looking at a clever way to solve difficult CXC mathematics examination questions. Here I'll be simplifying a complex question so that you can be able to do it quite easily. Here's an additional mathematics question. Suppose P is a two-digit number and Q has the same digits but in reverse order. The number P squared minus Q squared is a non-zero perfect square. The sum of the digits of P is... Explain how you got your answer and show calculations, assumptions, and deductions. Firstly, I must say that this question could have been better constructed by asking the question, what is the sum of the digits of P? However, let's get into the solution of the problem. First, let's try to understand the problem. Some salient points made in this question are: P is a two-digit number and Q has the same digits but they are in reversed order. It is also important to note that P squared minus Q squared is a non-zero perfect square. This means that if, say, P is 98, then Q will be 89. Note that P has the reverse digits of Q. And we also need to understand what are perfect squares. P squared minus Q squared can be either of the following. It can be 1, 4, 9, 16, 25, 36, 49, or any other perfect square. Note that 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, and so on. Let us now devise a plan to solve the problem. We can employ guess and check to try to solve the problem. This means we can try any values P squared minus Q squared if it would give me R squared. That is a Pythagorean triple. But if I were to try 98 squared minus 89 squared and I did not get the answer, and I moved on to 97 squared minus 79 squared and I still did not get the answer, I can keep on trying, but these will give me up to 90 different possibilities. For the purpose of examination, this is not a clever approach. Let us try another approach. This time we are going to look at logical reasoning with the use of expanded notation. Suppose I assume that P has the digits A and B. That is, A in the tens position and B is in the ones position. This means that Q would be the reverse. That is, B will be in the tens position and A will be in the ones position. The expanded notation of the first digit P will give me 10A plus B. This would represent the value of the number AB. The expanded notation of Q will be 10B plus A. This would represent the value or the expanded notation of the number Q. Remember, we require the sum of the digits of P. So if we were to sum these two digits, then perhaps this can lead us to the answer. So let us execute the plan. When I sum both digits, I will have 11B plus 11A. This factorizes into 11 into B plus A. There are several implications here. The first implication is that the sum of the two numbers is a multiple of 11. we can also deduce that the greatest value of the sum of two digits in any two-digit number will be 18. This is because the maximum digit in the tens value is 9, and the maximum digit in the ones value can be 9, and 9 plus 9 is 18. If the both statements are true, this means that the maximum value for this two-digit number that satisfies all these conditions would be 11. And so therefore, you can conclude the sum of the two digits is 11. Let us reflect on our answer to see if our answer is correct. Now, if we said that the sum of the digits must be 11, that means the two-digit numbers can only be either of the four numbers, that is 92, 83, 74, and 65. Simply because 9 plus 2 is 11, 8 plus 3 is 11, 7 plus 4 is 11, and 6 plus 5 is 11. These numbers would also be reversed because they said that Q will be the reverse of these numbers. Now let's check the perfect squares. 92 squared minus 29 squared will not give me a perfect square. 83 squared minus 38 squared will not give me a perfect square. 74 squared minus 47 squared will not give me a perfect square. However, 65 squared minus 56 squared will give me a perfect square, that is 33 squared. This establishes that the sum of the two digits must be 11, because 6 plus 5 is 11, and we have found a two-digit number which, when reversed, it will give me a perfect square. In other words, it's a Pythagorean triplet. This approach also gave us an answer that was not required. This gives us the exact two-digit number that was spoken about. So our answer is correct. The preceding problem was solved using Polya's problem-solving process. This process can be viewed by the videos seen in the description. Please don't forget to like, share, and subscribe.